Hi, so welcome to the Stat 110 2017 final live solve. This is problem 5 of this series. I have done the first 4 problems and hopefully the remaining problems by the time these are uploaded. Yeah, so as usual, I recommend you guys go ahead and take a look at this problem first before you watch me solve it. And yeah, let's get into it. So this is a fun exponential problem, IID exponential, sums, min, max kind of thing. I don't think I really liked this that much when I was taking the class, but now I really enjoy these kind of problems. But yeah, so the problem is two authors, Bob and Martha, are about to begin writing an epic co-authored book. Ethel the aardvark goes quantity surveying. It will take them A years to write. So that's our random variable. It will take them A years to write. Ethel the aardvark goes quantity surveying. When they finish this book, they will immediately begin working on a new individually authored book. So Bob will go off and spend X years writing the bilinear bonanza of Bonnie the butterfly, and Martha will spend Y years writing memoirs of Maud the magnificent manga bay. I don't really know what that is. Independently. So suppose that A, X, Y are IID expo lambdas, and on a timeline where 0 is defined as a time where they begin collaboration, consider the following quantities. So A is the time that Ethel the aardvark, let's draw a timeline. So 0, and we have like A is like Ethel the aardvark goes quantity surveying, completed. So like Bob and Martha are both kind of like working on that. And then next is B, the time. So that one is going to be just Bob's. So like Bob is here, that's going to be the bilinear bonanza, but from here to here, that's going to be big X. And then M is when the mod one gets finished. So from A to M, that's going to be big Y. And then T is when all 3 books are completed. So in this case, it's going to be here. Okay, but it could be equal to B or M, depending. So, all right, find the distribution of B, which is also the distribution of M. Okay, so we want to find, it's also the distribution of M because they're like symmetric. So looking at the timeline or the timeline here, we're looking for B, which is here, and that's going to be A plus X, which are things we know. So we're looking at the distribution of A plus X, where A and X are IID expo lambda. And just by the story, that means this is going to be, I don't know why I drew that line. I guess I want this like kind of like closer here. That means the sum of these is going to be gamma with 2 because it's like the sum of 2 of them, and lambda is a scale parameter because that's the same lambda from the expo. So just from like the representation or the story of the gamma, it's going to be gamma 2 lambda. Cool. So now find the covariance of A comma B. So I really like bilinearity. So since we already have this expression of A comma A plus X, and we don't really know that much about B other than I guess now we know it's gamma 2 lambda, but we want to kind of lean on the stuff that we know for sure in the problem. So it's going to be covariance A comma A plus X. And then by bilinearity, we can split this up into covariance A comma A plus covariance A comma X. And we know that they're independent, A and X. So this is going to be equal to 0. And covariance of the same thing is going to be equal to the variance of itself. So this is going to be equal to 1 over lambda squared, since the variance of an expo lambda is 1 over lambda squared. So that's this one. Okay, so there's just one more remaining. Find the expectation of T, the time at which the last book is completed. So what's happening here is that we have like let's express T as just like in terms of these A, X, and Y. So T is going to be equal to the, it's going to be equal to the maximum time of like bilinear and memoirs, because like that's, they finish A and they go off and do their independent books. And T is when all of them are completed. So it's just the last time, like here. And let's do one more thing. So this is A plus X, and this is A plus Y. And then this is going to actually just be equal to A plus the maximum of X plus Y, because both of them have an A in them. So we just need to figure out, like, the variable part is just the X and Y. Okay, and we know how to represent the like the max of X and Y from like kind of order statistics-esque thing that we've done in a lot of like the P-sets. I think like a monk question was in play here. And these like X and Y are both like expo lambdas is something that's relevant. But yeah, so let's just take the expectation and see what we have to do. So just by linearity, expectation of T is going to be equal to the expectation of A plus the expectation of this max. And the expectation of A, that one's pretty chill because it's like expo lambda. So this is going to be 1 over lambda. And then we want to find the expectation of the max. So to do that, I like to draw number lines. So we're looking for, like, first we're going to have like, we're just going to have like 2 expos landing here, and we're looking for the distribution of this one. So the waiting time for this first one, so let's call this T1. This is going to be distributed expo 2 lambda, because the rate is going to be twofold since we're waiting for 2 independent lambdas to come at us. This is like classic Poisson argument here. And then after that one, we use memorylessness. And now we're looking for, because this is also the min of the 2, which we've seen in the book is like expo, just the sum of the stuff you're waiting for. Now the memorylessness property allows us to reset, and we're waiting for just 1 expo to complete. So this one, let's call that like time 2, and that's going to be just expo lambda. So what we have here is going to be, this here is going to be expectation of like T1 plus T2, and each one, and then we can use linearity to split this up. Expectation T1 plus expectation T2. And expectation T1 is going to be 1 over 2 lambda. Expectation T2 is going to be 1 over just lambda. So all in all, we have first expectation A is this guy, and then we have 1 over 2 lambda, and then finally 1 over lambda as our, and this is like from the max part. And summing that all up, that's something like 5 over 2 lambda. Yep. And yeah, so that's it for that problem. Hopefully that was helpful, and good luck studying on the final. Yep, see you in the next problems probably.